and welcome back to the DevOpsCon Online Edition. My name is Dominik Mohilo and I'm editor for the German Java magazine and jugcenter.com. The following session is about serverless deployments with Canary, creating DevOps engineers at lego.com. And it is held by Nicole Yip, engineering manager at the Lego Group. Hi, Nicole. Before I give over to Nicole, just a little bit of information. You can use the chat and swap card to get help by our technical staff if there are any problems, but you can also use it just for chatting and commenting on the session. And more important, you can also ask questions via the integrated Q&A tool or via chat. If there's time, Nicole will answer the question after the session. If there's no time left, we will prepare a Q&A with Nicole and share it with you guys. And with that, I'm very pleased to announce Nicole Yip.
Ooh, thank you very much. Says host disabled participant screen sharing. Oh, wait,
yep, you can now.
Good now. So we'll share this one. Then I'll go to presenter mode. All right, how does that look?
Perfect.
Good. All right. So I'm Nicole Yip, and I'm going to be talking to you today about serverless deployments with Canary and how we're creating DevOps engineers at lego.com. So I'll start with a bit about me. I started at the Lego Group last year as a senior infrastructure engineer. And this year I got promoted to engineering manager, which means that I get to work even closer with the awesome people at the Shopper Engagement Technology team. I've been working with production workloads in AWS for about 4 years now. And as a side note, I also like to do bouldering and I like to do baking, but I haven't done much bouldering in the last few months and I've done a lot of baking. So draw whatever conclusions you like. So at the Lego Group, we're split into lots of different teams and lots of different areas. And the area that I'm in is the shopper engagement team. So we work on lego.com. Anywhere that you're browsing products, you're buying products, engaging with the site, that's what we look after. And if you hadn't heard, last year in July 2019, we went fully serverless. We went from an on-premise monolith into serverless in AWS in 10 months. So we wrote our first serverless service late 2018. We had about 20 serverless services in July, and that's what we went live with. We scaled up our team from about 10 engineers to 35 when we went live, and now we're at close to 50. We started with 2 squads building out the first services, and now we're up to about 7. I think we're adding on 2 more as well. So we did a lot in 10 months, and we're scaling even further beyond that. So what is this talk about? I'm going to talk to you about how we ran really fast. We went from our first serverless service, end of 2018, to going into production and hosting a global e-commerce website in 10 months. So we're now making it better. We're in this phase of improving our developer experience, improving our site performance. And we're essentially trying to make true DevOps engineers of the engineers within our team already. So I've artificially broken down the improvements that we've made into 2 phases. We started our first round of improvements just after we went live with shop.lego.com and just after we merged with lego.com to become the homepage. Earlier this year, we then started our second round of improvements as the first ones were still trickling out to the other squads. So the way that I've structured this talk is I'm going to quickly cover what I think DevOps is, because it's such a broad term. It's used in lots of different ways across the industry. And so I want to clarify what I'm talking about when I say I want to push DevOps out to the team and to create DevOps engineers. I'll then talk about what our constraints are within the shopper engagement technology team and where we were last year. So in July, what was our developer process like? What was our deployment process like? I'll then talk about what hurt as we scaled. We doubled the size of the team. We just over doubled the number of services we have built and now support. And then I'll talk through the round 1 updates, so the changes that we made to make things better. And I'll give you a preview into what we're working on right now. So what do I think DevOps is? It's the usual general definition of developers and operations working together, having some kind of shared understanding, having an empathy between the two teams, because it's very easy for the two teams of developers and operations to not trust each other, to be very counterpoint. They could work against each other, and I think it does in some companies as well. So developers are trying to push out new features that end users will want to use. Operations are trying to keep the sites stable and available also so that you have a good user experience. And so it's about streamlining the concerns of both parties. Developers want to push out new things, developers want to keep the site stable. And so we need to find a middle ground of what checks need to be put in place, what needs to be built into the services so that it's easy to operate, easy to debug. And the result that we're all hoping for is smoother, faster, happier release cycles. So I think DevOps is a mindset. It's something that you need to have as a developer or as an operations team. You need to be thinking in terms of automation and streamlining. It's enabled by tools. If you don't have automation, you're not going to get there. And it exists through people and culture. You need people to have the mindset. You need people to build the tools. You need the culture to keep those tools up to date and continually being worked on so that you're actively identifying pain points. You're actively making the changes to remove those pain points. And so what I'm going to focus on is how we focused on enabling DevOps by improving our tooling that was in place within the team. So what do I think a DevOps engineer is? Because this talk is about how we're creating DevOps engineers. I think a DevOps engineer can either be a developer who understands the concerns and issues faced when running their code in production, or an operations engineer who is involved in new feature development and QA to preempt potential production issues. So I've combined these two into what I think a DevOps engineer is. I think a DevOps engineer is an engineer with an end-to-end understanding of the DevOps lifecycle, who actively implements and updates tools and processes to streamline the release process while satisfying all concerns. And that's important. It has to satisfy all concerns, not streamline and eliminate and ignore the concerns of the other team. They're all valid and they're all there for a reason, to create really smooth end user experiences. So when I say the DevOps lifecycle, I mean this image. Anytime you type DevOps into Google, this is the first image you'll see. And I see this as leading into my description of what tooling, pipelines, automation, all of these keywords around DevOps, this is what ties it all together. So continuous integration. This is the continual merging of code back into a main repository by developers. And the idea is that small, frequent merges are less risky than long-lived feature branches that lead to merge conflicts or big bang releases. And that's what we're trying to capture with continuous integration. Continuous deployment or delivery is the continuous shipping of code, shipping of these small pieces that are being merged in by the developers out to production, all the way to production. Because again, you're reducing the risk of big bang releases. You're saying that I'm only shipping a small piece of functionality. So if something goes wrong, you know that the problem is in this small area, a very small surface area that you need to either debug or roll back. So the integration pipeline, I think, is the left-hand side. It's the planning, coding, building, testing, all of that happens continually or in small pieces or iteratively, however you want to call it. But that needs to happen for small pieces of functionality. The deployment pipeline is the right-hand side. It's the releasing, deploying, operating, and monitoring. So getting those small pieces of code through your deployment pipeline, which could be several environments long, through all of the testing into production so that it can be operated and monitored. And if something goes wrong, it feeds back into your backlog, back into planning, and you fix the bugs. And that's the deployment pipeline. That's the DevOps lifecycle. So what were our constraints? What are our constraints? Because DevOps is a mindset similar to how I think Agile is a mindset. So in Agile, it's a collection of frameworks, a collection of tools that you you pick and choose the ones that fit for your scenario. I think DevOps is exactly the same. There are so many tools out there, there are so many languages that you need to take your constraints, choose the tools and frameworks that fit your situation, and get them in place in front of developers and see what works. It's all about experimentation. That's why you hear a lot about metrics and testing and verifying if this thing works or maybe you need to change it up. So our constraints, the box that we're playing in is we have a monorepo. Actually, we have two monorepos. We have a front-end monorepo and a back-end monorepo. Eventually, we'll combine them, but the reason we had two is because we needed to have the two services be able to be developed independently. So we have a monorepo. We also follow trunk-based development. So we don't cut release branches. We don't maintain more than one branch at the same time. We have one main trunk that we call develop, and that when you merge into develop, you assume it's in production. Another thing to call out is that each service must be able to be released independently. This is important because we have a monorepo. So when you're raising a pull request as a developer, it's very easy to think, well, my service needs to call this one and I just need to expose one more field. So I'll make changes in both. The minute you do that in a monorepo context, it means that your deployment of this small piece of functionality is now dependent on two services, and you might need to deploy one first and then the other. So what we want to avoid is any kind of dependency between services, because that means that your pipelines are now tied together. You can't have the concept of this functionality lands for a service, it then goes through the pipeline on its own to production. Now we need to have someone monitoring the deployment saying, okay, no, I need to release this service first, and then I need to release that one. That's what we want to avoid, because that won't scale. Another thing that we're calling out is that all services must be tested in acceptance. We have 3 environments that we use for testing, and I'll go through them a little bit later in the presentation, but all services must be tested in QA, acceptance, and production. The reason for that is we need that middle environment so that we can test the automated deployment processes, so that we can test that the services truly are independent, that there is no downtime when we do a release. So I'm going to diverge a little bit here and talk about microrepos versus monorepos. So microrepos, I think, is something that most of you will be familiar with. It's the context of each service being in its own repository in Git. So that means that one repository is the workspace for that service. Anything that's in that workspace relates to that service. It means that whenever you raise a pull request and do a commit, you have a unique SHA per service version. So you can say that the SHA for this Git commit is the next version or a version of this service. It's definite. And the thing that you might struggle with is, how do we test things together? If you have 40 different microrepos for all of your different services, and you then need to deploy them into an environment, you then need to clone or pull from 30 or 40 different repositories. It's not impossible, and it's actually supported by most tooling, so that's all fine. We have a monorepo, so that means all of your services code, all of your tools, all of your libraries, all of your docs are in one repository. We use Yarn workspaces to try and give us that context of these are things that are related to one service. The thing that we struggle with a lot is that we have one Git SHA that represents the code in all of the services at this point in time. So it means that one SHA, for a single Git SHA, you don't know which service was changed in this commit. And another thing we struggle with is, how do you test things independently? How do I test this service without any changes from any of the other services? Because when you git clone, you immediately have all of the code. How do you make sure that you run just the one that you want? How do you know that if one service has bumped a dependency version, change the root level yarn lock file, and then when you build your service, you're then using the updated yarn lock file? So there's all sorts of things that we're working through by using a monorepo. And so the answer to most of those is custom tooling. Famously, Google and Facebook have monorepos across their entire organization. They have lots of custom tooling that they've developed to help make that process of managing the different services a lot easier. And they've even open sourced a subset of the functionalities of that custom tooling they've built. I think one of them supports Java, the other one I think supports Go. So they are quite language specific. They're related to the tooling used around the languages that they use most in their organization. And so that's why I'm saying DevOps is like a toolbox. There's all of these different tools out there. There's all of these different ways of doing things, and you need to find what fits your constraints the best. So into the case study, or into what we're doing. So in July last year, we had about 20 services in production. We were just going live with this global e-commerce website. And so what did our pipelines look like? They were all functional. We were able to deploy automatically to, we were able to do CI, we were able to deploy to our environments automatically. And so this is what the process is that we followed. Our integration pipeline. So developers would pick up a ticket from the backlog. We used Jira for backlog management. They would then create a branch to start working on this new feature. We use the serverless framework to build our services as well. And for building and testing, we use the serverless framework to build out a new service, update services, and deploy it to an AWS account, which we call Playground. So this is an AWS account that the developers have admin access to. They can deploy what they like there. They can test out new services. They can, it gives them an environment that they can see how their service is going to operate when it goes out and into the other environments. And once they're happy with that, they'll raise a pull request, and it will trigger a couple of the automated tests that we have. So it runs lint, it runs unit tests, it runs integration tests. And when they're happy, when it's been approved by one of their peers, it will be merged into develop. So I've got a little animation about what this looks like from a developer point of view. So let's say I'm working on service B. I'll make my changes, I'll deploy it to Playground. Maybe I'll make some more changes and I'll deploy it again. When I'm happy with it, I'll raise a pull request. And we have a monorepo, remember. So all of our services are in this one repository. And maybe I've just made a change to service B. This will trigger a CircleCI workflow to run all of the unit tests, all of the integration tests. It will make sure it can package all of the services. And in CircleCI, that's okay because they run in parallel, but it's not very efficient. So one of the changes that we made in phase 1, which I won't really talk about later because I'm focusing on the deployment pipelines later, but we introduced Learner to help us detect which service was changed in this commit and only run the unit tests and integration tests for that one service. So it means that we're a lot more efficient in how much in our use of CircleCI and in the workflows that we trigger. And yeah, that's all I'm really going to say about that. So we use Learner in the monorepo context to help us select which CI workflows to run. So when the pull request has been approved, when all of the testing has passed, we then merge it into develop, and this triggers off the deployment pipeline. So now that the code is merged into the main trunk with all the other changes that might have gone in since the developer branched off their feature, we then run unit tests again because now you're on merged code. We then deploy to QA, which is our first environment in the deployment pipeline. It then runs integration tests against this, and if it passes, it posts to teams. If it fails, it also posts to teams. And so this is the notification that a developer will get in our Microsoft Teams chat. And so they can see that their service was deployed to QA and it deployed successfully. It could say that it failed, in which case they'd have to check why the integration test failed. But yeah, that's what the integration pipeline looks like for us. The deployment pipeline looks like this. So you merge to develop, which is what the last part of what I showed you just before. It triggers the release pipeline in CircleCI to deploy to the QA environment. We then deploy through the acceptance environment, do some testing, and then we're ready to release to production. Once it's in production, we operate. You're in front of users. They're using your code. They're seeing your features. They start shopping. They start buying, and we're monitoring constantly. So we're using New Relic to give us insights into what's going on in production, and we have PagerDuty alerts to page our on-call engineers if something is going drastically wrong. I'm going to focus on the release and deployment pipelines for the rest of the talk, because that's where we made most of the changes. So I'm going to talk about the different environments that we deploy through. So we have the QA environment, which is a landing zone. All PRs are merged to here. We have post-merge tests that are running constantly, and we have browser tests that are running every hour. We have an acceptance environment, which is where release candidates are deployed. So when the QA team are ready to accept or to prepare a release, they'll make sure that the shards for all the services are deployed into acceptance. They'll then, this then triggers regression testing and end-to-end testing in Cypress. We also have a couple manual deployment steps because there are certain user workflows that we cannot automate. Things like checkout in Korea, you need to have a phone that's registered to a Korean bank that you can receive notifications for and things like that. So if a release candidate is making a change in that space, we'll test that as well. Once the QA team are happy that it's passing all of their tests, we then go to production. And here we have a check that will only deploy the service if it's been through acceptance. So we annotate the release candidate as it goes through. And we also only release if there's no active incidents or product launches at the time. So what does this look like from a developer point of view? So you've just merged your PR, you know it's deployed to QA, so you talk to the QA team. They then talk to the infrastructure team to then trigger the release. And this releases, it deploys the service to acceptance. So this is back in July, remember, when we had just gone live, we had about 20 services. This was kind of okay. We only had 2 squads at the time, and so they would talk to the QA team, infrastructure team would trigger the deployment, and then the QA team could test in acceptance. So as we scaled, you can kind of see a bottleneck forming here. So that's just to get to acceptance. What did acceptance to production look like? So once the QA team had signed off their releases, they talked to the infrastructure team again. We would then trigger off a deployment and that will push the service to production. So the way that we triggered deployments in the past was, we still use. So we use get tags to trigger a deployment. CircleCI can trigger off 2 different things, get tags or commits. And because we already had a commit and we didn't want long-lived branches, we went with get tags. So this was quite flexible because we had a relationship of potentially multiple services to a single commit. And so if you tagged a commit with the service name and the environment you wanted it to go to, this would trigger off the corresponding CircleCI workflow and deploy that service from that SHA, that Git SHA, into the environment that you've specified. So it was quite a flexible way of deploying. But there are quite a few alarm bells that go off in my mind just from reading all of that out. So we have an infrastructure team, a single team that triggers releases for each service. And back in July, we had 4 infrastructure engineers in the team. 2 were in the US. And so there was only 2 of us that were supporting this deployment process, along with all the other things that we were working on. There is some safety there. We have the wider systems knowledge. We know how the services are hosted. We know what's happening behind the scenes when we trigger a deployment. We can control when releases happen because we're also part of the on-call team. We know when incidents are happening. We know when product launches are happening as well. And so we can say, well, we're working on this rather than deploying your new service that could jeopardize the launch. So this is also prone to human forgetfulness, and it's slow and leads to environment drift. So if you're relying on new features landing in QA, you then need to talk through 2 different teams before your service gets into acceptance, let alone production. The tendency is for new features to build up in the QA environment, to build up in the landing zone and not be pushed through until one developer says, oh, hey, my feature went in, so now can you push that whole backlog of changes into the next environment and then into production. The other main the other alarm bell is that developers were not involved in releases. They talked to the acceptance, to the QA team, and then it was up to the QA team and infrastructure to get this feature live, not necessarily having the context of what the feature is. And so you lead to this disconnection from when they've built their feature to when it actually goes into production. So this is back in June. We did some talking, some workshops. We listened to developers and tried to find what the pain points were. And we came up with these 4: visibility, ability to recover quickly. We had unintuitive release triggers, and it was difficult to add new services or new pipelines. So I'll quickly talk through each of these points, as I'm sure it's not unique to us. So we couldn't answer these questions. What version of all services are currently in production? Has this particular commit for this service made it to production? Are there any services going stale in QA? Are there any new features there that haven't been released? Did someone just push to production? So we get notifications into Teams, just like when we're deploying to QA, we get a notification in Teams. We also get notifications when it goes to acceptance and to production. And when we only had one team that was supposed to be pushing to production, and then you get a notification on the Teams channel that something went to production, something happened, right? So that was visibility. That was the visibility problem. Another thing was our ability to recover quickly. So when something goes wrong, do you fix forward or do you roll back? Preferably fix forward, but how long does it take to fix forward? How long does it take for a developer to raise a fix, raise it into PR, get the PR test to pass, get it into QA, talk to the QA team to get it into acceptance, and then get it deployed to production? If it's a really big issue, if the site is currently broken, that's too long. So then who has the permission or knowledge to roll back? Normally that's the infrastructure team, but that really shouldn't be the case. We also had an unintuitive release trigger. So pushing a git tag to deploy to a specified environment, those two naturally shouldn't connect in your mind. Pushing a git tag shouldn't correlate to, okay, my service is going to be in production now. We also had to use force pushes, which overwrote existing tags, which means that you didn't know what the previous version of the service was in production. It requires confidence with Git. Tagging and force pushing tags, it's not something part of a normal developer's Git flow. And also there's no contextual confirmation step. Normally you would have some kind of protection of, I want to release this thing. And then you would have a pop-up saying, are you sure you want to release this thing? And it's always in the context of, you're about to release a service to production. Pushing a Git tag, you don't have any of that. And there's no UI available. Some developers have a lot more confidence if you have a UI that's telling you exactly what's going to happen and saying that when you sign your life away, this is what you're accepting. The last thing that we had was it was difficult to add new services. So if you've ever used CircleCI, it's a YAML file and it contains configuration for all of your deployment pipelines. So we had our CI pipelines, our deployment pipelines for all of our services in this one file. And we have a monorepo, right? So we had, at the time, it was 20 services. So it was manageable, if you can call 2000 lines manageable. So adding a new service was as simple as copying and pasting in several places in this 2000 line config file. You would copy and paste some filters, you would copy and paste the integration pipeline, and then the deployment pipelines. So in March 2020, no, by March 2020. So we had identified all of these issues. We started putting in place some changes. And so by March this year, we had most of these things in place and they were just trickling out to the rest of the squads. So the first one that we tackled was the ability to recover quickly. To do this, we used Canary Deployments. So because we're using the serverless framework, we use the serverless Canary plugin. And all you need to add is the deployment settings for your function. And then you tell the deployment you tell the plugin which type of traffic shifting you want and what stages to for this to take effect in. So there's a link. This uses AWS Code Deploy behind the scenes. So you can see that with AWS Code Deploy, you have pre-deployment validation, you have a traffic shifting component, and then post-deployment validation. So one of the other nice things you get with AWS Code Deploy is this manages lambda versioning for you. And it also manages an alias that we called live, but this just denotes which of your versions is the one that's actually being used in production. And so you can see in the Lambda console, it's got the active weights of what amount of traffic is going to each of your versions. So you can see what is it traffic shifting against, how much of your traffic is going to the old version, so version 14, which is 90% at the moment, and what percentage of traffic is going to the new version, which is version 15, and currently that's 10%. So we had Canary in place for long enough that we decided we wanted to change deployment traffic shifting types. We started with Canary 10%, and then we changed to linear 10%. So what is the difference between those? Canary 10% means that it shifts 10% of traffic in the first increment, waits for 15 minutes, and then sends the rest of your live traffic to this new version. That's fine if you have a service that's being hit all the time and you have like 10% of that traffic is enough to test out this new version of the service. We have quite a few services that aren't called that regularly. And so we decided that linear 10% was a better fit for us. This shifts 10% of traffic for every minute until you reach 100%. So this means that you're slowly introducing more and more of your live traffic to this new version of the service, and you're more likely to trigger off alarms if something is going wrong with this new version. So the idea with Canary is you implement these alarms, which we use 2 plugins for. The serverless plugin AWS Alerts is written by A Cloud Guru, I believe, and we use that for implementing an alert on if the new function is being throttled or if it's throwing errors. And we've written a wrapper around, I think it's that same plugin, but we've made it for API gateway alarms, and we've implemented some defaults that suit us. So now we have alerts exposed for high 4xx, high 5xx error rates, also high latency, or even a not invoked. If we're expecting an endpoint to be invoked every 5 minutes, half an hour, 1 hour, we can set an alert for that. And so if any of these alarms go off, that will signal to AWS Code Deploy to roll back the deployment. It means that it will switch the live alias back to your old version, and now you've got automated rollback, essentially. So it's a safety net for our developers who we're trying to encourage to push to production and not be bottlenecked by an infrastructure team. So that is why we implemented Canary deployments. The next pain point we tackled was unintuitive release triggers. So we redesigned our deployment pipelines. So we already had the pipelines in place. It's just that we triggered them by tags manually. So everything in yellow is what we had before. So when you merge to trunk or merge to develop, it runs the test and verify pipelines. We then have a selector script to only deploy the service that was changed in the commit. We then added the step that triggers the acceptance workflow. So this means that as a developer, you can test your change in QA. When it's ready, you can talk to the QA team and say, hey, I'm going to push the service to acceptance. You don't need the infrastructure team. You don't need to know Git. You find the workflow in CircleCI, the one that says acceptance hold, release the hold step, and it starts deploying to acceptance. Similar to going to production. When the QA team are happy, they've signed off the release, maybe for this particular service, the developer or the development team were able to verify an acceptance already. The deployment to acceptance triggers off the deployment to production, which starts with a hold step. So all the team needs to do is find the deploy to production workflow, release the hold step, and it starts deploying to production. So you don't need to know Git, you have a UI, you have contextual information of you're in CircleCI, you're in the deployment application, and you're releasing a hold step. You know that this is the only gate between your service being in acceptance and being deployed to production. And this is what it looks like in Git. This is what makes it easy to find the workflows for the commit that you made and for the services that you changed. So that's how we tackled the pain point of having an unintuitive release trigger. So the one thing I didn't mention was that in this Git view of all the commits in your repository, the commit above could be for a completely different service. The commit below, another service again. And the only way you can find out is if you click on the little cross or the little orange circle. And so you can find the workflows, but you need to remember where your commit was, where it landed. And so the next thing we tackled was visibility. How do we know when and where things are deployed? We created mission control, which is a Next.js static site hosted in S3. We have data that is fed back from the deployment pipelines. So if you were very eagle-eyed, you might have seen some of these steps that say update mission control, but it's been truncated. And so we get data from the deployment pipelines saying this service went to this environment at this point in time, and it was this commit, which means that we can list out all of our services across the front end and back end monorepos because they all follow the same deployment pipelines. Yes, the steps within them might change, but the pipelines are still in line. And so you click on your service on the left-hand side. You then see all of the commits that are relevant or have made changes to your service on the right-hand side. So you know that you have the context of all of these commits are changes to this service. You can then say for each commit, when did it land in QA? Did it go to acceptance? Did it go to production, and when? And so you can clearly see if something is building up in QA. You'll see a lot of yellow boxes on the right. If something is being deployed to production, which is the goal of each of these commits should go all the way through to production. So the goal is to have the right-hand side filled with blue boxes to show that it's been deployed. So that's how we tackled the visibility problem. And the last one is it was difficult to add new services. So we now auto-generate our CircleCI file. I mean, all of the workflows follow the same pattern that I talked through before. And so we can now template that out with a couple adjustments. So the developers can add a CI_config file, which says, actually, I want to run integration tests in QA. I also want to run integration tests in acceptance. And they can customize things like that, adding or removing certain steps. And so this means that they don't need to copy and paste through a 2000-line config file anymore. They run the generate config script that builds out based on what their directory looks like at that point in time. And so now it's easy to add new services. You add a new directory that follows the naming convention. It'll add a new pipeline for you when you run the generate script. And with all of the changes that we made to connect up all of our deployment pipelines, the config file is actually closer to 9,000 lines. So thankfully, they don't need to copy and paste through that. And so looking back on that, we actually changed quite a lot. And that was only 4 pain points. And I've artificially grouped these into round 1 and round 2. A lot of these landed one after the other or as we identified them. So this is a continual process of us looking back and saying, what are we hearing from developers? What are we hearing from the operations team? And so what I've artificially captured as round 2 is what we're working on right now, what is in the process of landing, in the process of being rolled out. So we're currently working on monitoring and alerting and getting this feedback back to squads. We're not keeping it in the domain of PagerDuty and the on-call team anymore. We're passing all of these alerts back to teams. We're actually sending some of those alerts to the squads that own those services. And so we're in the process of getting squads trained up in when we receive an alert, what are we supposed to do? How do we tune an alert so that we don't get as much noise? We're also looking at implementing distributed tracing. We've got it on most of our services now, but now we're looking at the visuals that we're getting. What can we use when something goes wrong in production? What is the landing page that we need to start with so that we can track through efficiently to find where the issue happened? We're also designing what a front-end connected playground looks like. Because we have 2 monorepos, we have a front-end and a back-end monorepo. Our difficulty is how do we test those 2 monorepos together? So it's a hybrid of the microrepo, monorepo issues. So that's what we're designing and thinking about at the moment, and probably will be the next thing that we tackle. In terms of people and culture, so we focused on tooling a lot in the last year, and now we're starting to tackle people and culture. So we're training up developers on how do you follow the release process? What do you need to verify at each stage in each environment to know that your feature is going to be successful in production? We're doing operations training. We actually increased the size of the on-call team by about 4 engineers. And so they're getting used to receiving these alerts, reacting and triaging issues that come through on the production site, not just in the context that they're aware of, but across the whole site. So they may work on just checkout, but they'll get an alert for VIP and they'll have to figure out if it's a Sev1. If it's a Sev1, they need to start the major incident process. And so this is all getting our engineers closer to end-to-end service ownership. They're building their services. They're now getting more involved in operating and responding to alerts. And we're giving them the tools on monitoring and alerting and tracing through all of the things that are happening in production. So to summarize, DevOps is a mindset. It's a culture, and it's enabled by tooling and people. You need both. You need all three to succeed with DevOps. We started out with functional pipelines. We didn't make that many changes. We added, a couple steps here and there. We added a dashboard, but the pipelines themselves have stayed the same. We identified pain points affecting both the developers and the operations teams. We then modified and added to this process with the pain points in mind. And this is all getting us closer to our developers becoming DevOps engineers. And that's the end of my talk. So I'm Nicole Yip. You can follow me on Twitter, PelicanPie88, and check out our Medium publication because we're publishing lots of cool things about what we're doing in the serverless space and what it's like to work in the shopper engagement technology team. So thank you very much for listening and have a good day.
Thanks, Nicole. Awesome talk. Usually the audience at the conference would now give you a round of applause, but maybe you guys at home can use the chat for clapping. There were 2 questions actually. Tom Bullock wanted to know the name of the tool you used to only run specific tests based on code changes.
So we used Lerna, L-E-R-N-A. Because our site is written in Node.js and JavaScript, Lerna is a JavaScript-based library and tool that we use.
Mm-hmm. And the second question is there any challenge to maintain and update each microservice pipeline, as most changes on the pipeline code that you do are common throughout all microservices? Yes,
so we have a generic pipeline that we use for all of our services. And that's what enabled us to template out and script out the generation of the CircleCI config, of the workflow config. So that means that if we need to add a step to all of the services, we can add that into the generation script. And then it's as simple as running that command, committing it to GitHub. And when it gets merged, all of the services will now follow that. We also have the CI_config file, which means that we can put in optional steps as well. So if we have one service that needs to do one special thing, maybe they need to also deploy, I don't know, maybe they have a separate serverless file that they want to deploy somewhere else at the same time. We can add in a conditional step that in the CI_config file, you need to set a flag. And because the flag is only set in one of the services, that's the only pipeline that will have an additional step. And so we have a lot of flexibility in the pattern that we're following now.
Okay, then thanks again, Nicole. Thanks to the audience for attending and have a nice time at our conference. Please don't forget to rate this talk in Swapcard. There's a 5-star rating system included in the tool. So it would be nice of you all to give a little bit of feedback. And with that, I'm saying, have a nice day.
Thank you.